All right, so last week we looked at basically our rules with exponents. Okay? When do we add exponents? Okay, when do we multiply them? Okay? All the problems that we just went over. The only thing we haven't talked about yet is what happens when your exponent is a negative. Okay? Generally, we don't like to leave negative exponents in a problem. If we can, we like to make them positive. And if we do that, you can use all the rules you already know. Okay? So first thing I want to do is forget about 2 to the negative 1, 2 to the negative 2. Let's start with like 2 cubed, 2 squared, 2 to the first. Okay? And Mr. Roy has a spot for this. This is an example on your note sheet.
And you'll see on the top it says 2 to 0. Well, you'll see when we do it, you'll have it on that.
Okay, so I'm going to show you guys a pattern, and I bet you're going to be able to figure out what these top 3 are, even though we haven't talked about them yet, just by the pattern. Okay. Who can tell me what's 2 to the third power? 2 cubed. Marcus?
8.
8. Okay. Now we're going to go down to the next one. 2 to the second power. Savon? 4. Okay. Let's go down to 2 to the first power.
2.
Victoria? 2. Okay. Now what I want to do is look at these 3 numbers. Look at the pattern. How we got from 8 to 4. What do you do to 8 to make it 4? And what do you do the same thing from 4 to make it into a 2? Divide it by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. What's 2 divided by 2? Let's do it one more time. 1. 2 divided by 2 is 1. Let's keep going. What's 1 divided by 2? So if you had $1 and you split it in half?
50 cents.
Right, 0.5 or 1/2.
Can we actually do that?
Okay?
Oh, so we get fractions instead?
So what happens with a negative exponent is you get a fraction. Okay. What about, this one's a little tricky. What do you get when you take a half and divide by 2? 1/4. Yep. Okay, so most of you knew these 3 pretty good. Okay? And what I did is I used these 3 to show you the pattern. Divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. Okay? So as Isaiah already said, negative exponents, look what happens. Fraction. Okay? You get a fraction. This one's important too. To the 0 power. Okay, we're going to talk more about that, but in general, anytime you raise something to the 0 power, you're always going to get 1. Okay? Okay, 9 to the 0 gives me 1. Somebody else, give me another number. 4. 4 to the 0, 1. Give me one more.
80.
80. Okay, anything to the 0 power always comes out to 1. I think we have that in the rules, right, Mr. Roy?
We'll be writing that in a second.
Okay.
So like this, then you're gonna just roll the board. Thus, we can see, right? You're gonna write. On your sheet, it already says any, right? You're gonna put non-zero number raised to the 0 power is 1. So you already have any on your sheet. You're just gonna write non-zero number raised to the 0 power is 1.
Okay, there was only, when I asked you guys for numbers, there was one number I was hoping nobody would say to me.
0.
And that's 0. Okay, because I said to you, anything to the 0 power is 1. Well, almost anything. Okay? As long as you don't do 0 to the 0.
So what's 0 to the 0?
Okay, let's try typing it. Does everyone have this before I bring up the calculator?
Yeah.
Okay, well, you might think, okay, because it has an exponent of 0, it should be 1. Right? Based on the pattern.
No, it's supposed to be 0.
Well, if you take 0 and raise it to any power, it just means to multiply 0 by itself 4 times. So what would that be? 0. Okay, so you might think if you take 0 and raise it to a power, you're just multiplying 0 by itself, you should get 0. But we just said earlier, anything to the 0 power is 1. So it's kind of like you think there's 2 things that could happen. Turns out neither one of them works. So if you try to raise 0 to the 0, you can't do it.
It's basically impossible.
Yeah, can't do it. It's undefined.
Error.
Yep, so on a test, if you see this as a problem, 0 to the 0, write
No solution.
no solution, undefined. This is the only problem you can't do with exponents. Okay? If I change the 0 to some other, the lower 0, the base, to some other number, works fine. Change the exponent to some other number, works fine. You just can't have 0 to the 0.
Mr. Hager, even if that base is negative, it would still come out as 1, correct?
If the base was negative?
Yeah, it's like
Yeah.
negative 5.
Okay, so Mr. Roy is going back to what we just wrote up here. Any non-zero number, even negative 5 to the 0, would still be 0. How would I type that in? Anybody remember? What do we have to be careful of?
Well, what are we going to make sure we're going to put on there?
1.
No? Yeah.
Parentheses.
Yeah.
Disease.
Yeah, one
It's
is.
not from text. It's not from text.
What would happen if I left the parentheses off?
It wouldn't, the answer wouldn't be right.
Okay, guys, what would happen if I left the parentheses off? Would I still get 1?
No.
No.
I get negative.
I'd get a negative 1. It would basically do 5 to the 0 and slap a negative in front. Okay?
That's what I would do.
So guys, you have a spot on your note sheet where it says example 1A. You're just going to write, you're going to write in that example right there.
Are we gonna solve it?
So we're supposed to write that example on there?
Yeah, it says example 1A right there.
Oh, I wrote it on
That's fine. That's fine.
Okay, so there's nothing here you guys are going to solve. You're just going to simplify what you can. Okay, it's not like when we're done, we're going to have an answer for x.
Isn't that like 4
Yes.
plus 1
Well, what operation is between 4 and x right now?
multiplication?
Right, think of it as multiplication.
So it would be like 4. The answer, right? It would just be 4.
Nope.
Yeah, what's this part? How'd you get that? What's x to the 0?
0.
It's 1.
1. Okay.
Told you.
Remember, anything to the 0 power is 1, except 0 to the 0, but in this case, x is not 0. If it were, that'd be a problem. And then Isaiah just said 4 times 1, we get 4. Okay, in all these problems we do, I'm going to write down variable is not 0.
Is that what we wrote on the, oh.
Yeah, if it was, you wouldn't be able to solve it.
And then on the little, you have a little line where below that 0 it says each constant or number and variable is treated separately. Make sure you write that on the line, okay? Because I know some people right away, I heard them say it, when Mr. Hager was going over it, they said, yep, it's 1. Remember, this is separate. It's 2 separate things. The 4 and the x to the 0 aren't attached. All right? We could have, if it makes sense to you, we could have wrote it with parentheses around it. All right? But we haven't done that all year. 4 with x means 4 times x. You have to treat these things separately. So it's 4, x to the 0 becomes 1. Right? So don't fall into that. That's why in the warm-up I said you're going to make sure that you treat it separately. All right? Make sure you remember that, okay?
All of these example 1 problems, these are going to be really, really quick problems. Okay, anyone raise your hand if you think you can tell me what that is. Remember, the variable is not 0. Isaiah?
That's an equal sign.
Yep, I want to know what this equals.
Oh. Instead of m, shouldn't that be like a 1?
5 to the 0, m to the 0.
Okay, we could use that rule.
But it says variable is not 0.
This is fine. So, Caleb broke it up the way we've done before. Basically, you raise the 5 to the 0 and the m to the 0. That's fine. What's 5 to the 0 power? 1. What's m to the 0 power? 1. So it's 1 times 1, which is 1. That's perfectly fine to do it that way. Or if you just recognize right away, you've got something to the 0 power, the answer is just going to be 1. Right? Okay, this rule that Mr. Roy wrote right here is basically what we just did in the last problem.
So you wanna add that to your sheet.
Okay. I didn't write the powers in, but what are the powers if you don't have them? 1, 1. So we multiplied the 0 exponent to the 1 on the exponent of the 5 and the 1 on the exponent of the m. Okay, anybody have any questions about this second rule Mr. Roy wrote?
Guys, what I just gave you is just like we've done in past weeks, it's just the example sheet. Notice that it's, the example spaces are blank. You're gonna have to actually write those problems.
That's probably enough for that sheet today.
There might be a little bit more. Yeah, it's gonna be a little bit more coming up, we'll let you know.
Okay, again, same type of problem we just had. The exponents aren't written. By now, we definitely should know what they are. They're both 1s.
So example 1C is going on your example sheet that I just gave you. It says 1C in Mr. Hager's writing, then it says blank, you can write it right below that.
Okay, Spencer, can you tell me how to use that rule we have right above it on this problem? What do I do here? So what do we do? Same thing we did up here. It's exactly the same thing. Yep, how do I write it out?
X in parentheses with 1.
With a 0?
And then a y with a 0 equals 1.
Yeah. Okay. So we're taking x, raising it to the 0 power, y to the 0 power. As long as the letters aren't 0, which I said they weren't, anything to the 0 power is what? 1. Okay. Really simple problems. Okay, we pick some basic ones to start with. Okay, what's the difference between 1C and 1D? I mean, besides that I have a 7 and a y and an x and a y. I know the x and the 7 are different.
Parentheses.
The parentheses. Do those really make a difference?
Yes.
Yeah. The difference they make is if you put parentheses around it, you're raising the 7 and the y to the 0. Right now, it's just what raised to the 0?
1.
No, why?
Just the y. Just the y. This 0 has nothing to do with the 7. Okay, so I have 7. What's y to the 0? 1. 7 times 1? 7. Good. Okay, so we didn't put this up because it's difficult. We put it up to show you the difference between 1C and 1D. Big difference in the answer you get.
Yeah. That, if there's parentheses, apply the 0 power to both. If there's no parentheses, just apply it to whatever it's next to.
Okay, guys, any question on example 1? Okay, everyone got 1C and 1D? Good? All right. So this next part, Mr. Wright, you're just going to watch this part, right?
Yeah, guys, we're just watching right now. Mr. Hager's just showing you why it works that way.
Okay. Earlier, when Mr. Wright did the warm-up, he showed you guys this, right? This exact thing. Okay? You're left with 1 divided by 6 cubed, right? So you always put the answer where the bigger amount of numbers was. In this case, we had 2 6s in the top. We had 5 in the bottom. There was more in the bottom. The answer goes in the bottom. Any question on how you get that?
We showed something like that in the warm-up too, guys.
Yeah.
Whether it's numbers or it's letters, it still works the same. Right? Some of you guys last week on the test wanted to multiply those two things together and put like 36 to the third. It doesn't work that way. Keep the base the same and subtract the exponents, whether it's a number or a letter.
So as Mr. Wright just said, all you do is subtract the exponents. Larger minus smaller, put the answer where the larger exponent was. Now, the reason we did it that way was to avoid negative exponents. Okay, that's the whole reason we taught it to you the way you did, so you didn't have to worry about it. But if we wanted, we could just subtract them the way they are. Okay? If we subtract them the way they are, we'd have this. This is not wrong. We didn't teach you guys to do it this way because you're going to end up with a negative. What's 2 minus 5? It's negative 3. So what's in that box and what's in that box above it? These are both correct. What does that mean? If they're both, these are both correct.
That there's two ways to answer it.
Yeah, there's two ways to do it. These are the exact same thing. Okay? And if you look at this and you look at this, they're almost the same thing. The only difference is this has a base of 6, has an exponent of 3. One of them's negative, one of them's positive. So we're going to learn a trick with a fraction that takes an exponent that has a negative and turns it into a positive exponent just by using a fraction. So this is the important idea. These two things are exactly the same. In general, we don't want negative exponents. So we're going to use this trick to make it positive. Somebody already said a word begins with R. What did somebody say? Somebody said it earlier. What's the word begins with an R?
You flip a fraction.
Yeah, who just said it? Yeah, reciprocal. Okay, that's exactly what we're going to be doing. We're going to be flipping things. Okay, so this is going to give us a rule. This is going to give us a way to get rid of negative exponents. If we can get rid of negative exponents, you guys can use the same rules you already know. Okay, that's the goal. Get rid of the negative exponent. All right, so I'm going to show it to you first as an equation, and then we're going to write out what this means. It's a lot longer to write it in words, but I think it'll make more sense. Okay, look at this first one. You have b and you have a negative exponent. Where's that b to the negative n? Top or bottom?
Top.
It's in the top. Well, if you want to make it positive, just take it, throw it down in the bottom. Look what happens when you do that. All of a sudden the negative disappears. Now look at this other one. Where's the b to the negative n in this fraction? Travis? Where's the b to the negative n in this fraction? It's in the bottom. If we want to make it positive, all we have to do is put it in the top. Right? So anytime that something passes through this line right here, think of that as like, Mr. Wright, how did you explain that? Like the magical line?
Yeah, this switches it. This when you move it, it makes it positive.
Yeah. Anything that moves through that line changes the sign of the exponent. Okay. So this is how we can write out what we just said.
I'm not saying you wanted to do it, but if it was b to the positive n on the bottom and you flipped it to
Yep.
the reciprocal, would it become a negative?
Yep. Yep, you could do that. Like if you had something that was already positive and you moved it, you would make it negative. Very good. Yep. In general, though, you don't want to do that.
Yeah.
Yep. We'll just take things that are negative and move them. Okay, so this one says if you've got a base with a negative exponent in the bottom, move it to the top. Once you move it to the top, that's going to make the exponent positive.
So on your sheet, guys, it says negative exponent in the bottom, move base with exponent to the, how would you fill in that blank? We're on those two bullets right in the middle of the page. It says negative, huh?
Top.
Yeah, move it to the top, and then the second blank would be what? And make exponent
Positive.
positive. So those two blanks for that first bullet are going to be top and positive. Top and positive. Top and positive. Guys, if you're not sure about that, I can come around and double check, okay? So,
Let me show you guys, let me show you one with numbers. Okay, here's a problem where you've got base with a negative exponent in the bottom. what do these directions say to do? To make it positive.
Move it to the top.
Yeah. Take this, the base, and whatever's attached to it, move it to the top. If you do that, you get that. That's how you take something that has a negative exponent in the bottom, move it to the top, and it becomes positive. Now, what do you think is going to happen if you have a negative exponent in the top? Where are you going to move that?
Bottom.
You're going to move it to the bottom. So, Mr. Roy, they got a spot for this too?
Yeah, just fill in the blanks again. So, Mr. A, can you circle this bottom and positive? So what Mr. Hager circled, that's what you're going to fill in your blanks with. So that's second goal. Yeah, bottom and positive. You move in that fraction bar. That's just the way the rule works. It's gonna make it positive. This switching word is take the base and the exponent with it. All right, but you gotta understand. We want to show you a little bit later. If the base is negative and the exponent's positive, you'll leave it. It's only when the exponent is positive, negative rather. It's only when the exponent is negative. If the base is negative, it doesn't matter. It only applies to the exponent.
That's what Mr. Roy is saying. We don't care, but this is fine. Okay. Exponent's positive. Leave this alone. This is a problem. Okay, negative exponent. So if you have a negative exponent and it's on the top, where do you move it? Move it to the bottom. Whole thing goes down in the bottom. And if you wanted to do that out, this is small enough you could do out 5 squared. 5 times 5 is 25. Okay. But for now, I just want you guys to see where you move stuff. Okay, all the other properties that we already learned, they all still work. Okay? They all work.
Guys, this one's on your on the sheet we gave you at the beginning of class. This example is on there.
What?
On the note sheet that we gave you at the beginning of class, example 2A is on there. We're bouncing back to that now.
Right, now, if you've worked with negative exponents before, there's many ways you could do this problem. Okay, my suggestion is going to be anything that has a negative exponent in it, get rid of it right away. Okay, anything that has a negative exponent, get rid of it right away. Okay, anybody tell me anything up here I should circle that has a negative exponent?
Negative 8. 3
Yeah.
to the negative 8.
Yeah, remember, these are attached. That 3 and negative 8, those are stuck together. Okay? How about 3 to the 5th?
Nope.
Leave it alone. Okay? This is fine. If you're confused and you want to see fractions, you can make them fractions. What am I going to do with 3 to the 5th? Do I want to take and put it in the bottom?
No, keep it on top.
Keep it in the top. It's already positive. Don't touch 3 to the 5th. Okay, if you want to keep it as over 1, that's fine. What are we going to do with 3 to the negative 8th?
Put it on the bottom.
Put it on the bottom. Why put it up? What happens when you move it?
Turns positive.
The exponent becomes positive.
So we have this. Now we can't leave the top empty. We've got to put something there. We just put a 1. Okay, and now when you multiply these fractions, just go straight across the top. Eli, what's 3 to the 5th times just 1? Yeah, that's the same. Okay. What's 1 times 3 to the 8th? Shelby? 3 to the 8th. Now, some of you might see a quicker way to get from point A to point B, what we just did.
Yeah, I might show you a different way too. But Mr. Hager's just showing you exactly step by step what it looks like.
As I said, many other ways you can do this. Now we've got a problem that you would have seen on the test. Subtract your exponents, write your answer where the bigger number is. Okay. What's the difference, Ben? 8 minus 5?
3.
3. Okay. Where does the answer go? Top or bottom? Bottom. Perfect. So my base was a 3. Just a coincidence, that stayed the same. 8 minus 5 is 3. Put the answer in the bottom.
Don't multiply those constants. You don't need to. Treat the same as you would variables. Like when it's x and x, you don't make it 2x. You leave it as x. All right? Same thing here. Keep the base the same. All right? Remember, where it said you have a little space on your sheet with a little asterisk there, right? Remember, you're going to put multiplication problems over 1. When you have negative exponents and you're multiplying, make sure you put them over 1. You have space on your sheet to write that. Spencer, you know where I am? Did you write that in? Write that in. Write that in. Put, you have a little bit, right under example 2a, you have some space, right?
So, do you guys want me to show you a different way to do it, or do you want me to show you the same way?
Which one's easier?
They're both pretty. I mean, it's no harder than what we just did. I think it's a little less writing.
Yeah, well, let's do the other one.
Okay. What's my exponent on a?
-7. Oh wait, a.
Just the a,
Yeah.
not the b. What's the exponent on my a?
1.
Yeah. So that's a 1. Are there any other a's in this entire problem? No. So that a isn't going to change. It's going to stay the same. A. Now we have 2 b's. What operation are we doing?
Multiplication.
Multiplication.
Listen, I was thinking something else.
What's the rule when you have 2 letters with the same base? We did one in the warm-up. What do you do with your exponents? You add them. Good. Okay, so we have -7
Marcus, you're not helping yourself, buddy.
Negative.
plus -3. Okay, all we're doing is we're taking our 2 bases, we're adding the exponents. -7 plus -3.
-10.
Yep. Now there's only one problem with this answer. What do you think the only thing that's wrong with that
There's
is?
still an a by itself.
The a is okay, something wrong with the b.
Oh, it's a negative.
Right. What do we do with this to make it a?
Over 1.
Right. We're going to put it, remember, think of that as your fraction. You're going to take that b to the -10 and put it where?
1.
In the bottom. When you move it, what does it become?
10.
A little bit more.
A over B, B something.
B10.
B to the 10th. Good.
Positive.
Okay, so if you want to do it this way, this is fine. Multiply letters with the same base, just add your exponents. Okay, at some point you got to deal with the negative. Either deal with the negative right away and get rid of it, or do the problem using the rules you know and get rid of the negative towards the end. But you got to do it somewhere, either now or later.
All right, guys. So the last one is we're gonna go back. I think that's actually we're gonna do one on the note sheet that we gave you at the beginning, right? That we put all the rules on and stuff. We're gonna put one more example on there. But this next example that we do is gonna go on your example sheet. All right, the one with the example letters and the blanks. All right. So it says right here, right on your example sheet. You have example 2C on there, and you have blank space below it. We're just gonna write it in there. All right. So one way I do it, kind of along the same lines of what Mr. Hager does. What I do, when I see it's a multiplication problem, it has a negative exponent, I take the whole thing and I put it over 1. Right away. I take the whole thing and I put it over 1. And then I put my fraction bar over here. And I look and see if I have positive, as I'm going through systematically, I say to myself, if I have some negative exponents, I'm gonna move them. If they're positive, they'll stay on the top. Because anything we write in math, we can put over 1. Any whole number, all right, any variable, we can put it over 1. So I'm going through. The first thing I got is 9 to the -4th. Justin, what's gonna happen with that? Huh?
I didn't raise my hand.
I don't know, I want to ask you to see where you're at.
Well, I don't know.
You don't know? But haven't we been talking about this? If we had negative exponents, what we were going to do?
Positive.
And how do I do that? You know how to do it? Sure you do. If it's a negative exponent on the top, how do you make it positive? Not subtract it.
Does it change it?
Huh?
Does it switch things?
We're gonna move it, right? We're gonna keep, Justin, we're gonna keep that base of 9, but see how I put it on the bottom? Stay with me. Don't worry about what these guys doing. Don't worry what Travis is doing. He's not gonna do you any favors by laughing at you. All right? So we got 9, right? We had a negative exponent up here, right? On the bottom, what's it gonna become? Positive, right? That's the rule, Justin. That's why I asked you, because I wanted to see where you were at. All right? If you have a negative exponent, all right, wherever it is in the fraction bar, keep the same base like we did here, 9, and then it's move it to the opposite spot. It's in the top here. Keep the base, make it positive in the bottom. That's how it works. So we took care of this. All right? Ryan, I got 9 to the 6th here. What's going to happen? Okay, but if I'm doing something like this, I don't have to do that yet. When we get to the end, we'll do that, and we have to simplify. Is this going to move or anything like that? Is that going to stay on the top? Let him answer for himself. Is that going to stay on the top, or is that going to be moved to the bottom? It's going to move to the bottom? Well, let me go back here and show you what I was talking to Justin about. Justin had a negative exponent, and we moved it to the bottom. Here, is the exponent positive or negative? Positive. So, no, we don't have to move it, right? Keep the base, keep the exponent. Nothing had to happen there because it was positive. The exponent was positive. Remember, if the big number, if the base is negative, it does not matter. We're only talking about negative exponents is when we're going to move it. If the base is negative, it stays. If this was negative 9 to the 6th, it wouldn't matter. It would stay as negative 9 to the 6th because the exponent's positive. Okay? So I come to now I'm at my last part. Division. Anybody want to take a crack at it?
9 over 3 over 9 over 2.
So 9 over 2, where? Top or bottom? Say Vaughn. Bottom?
Yeah.
I disagree.
What am I dividing by?
Huh? Remember, when we do this, right, we keep the base, which is 9. 9's the base. All right? And I subtract the exponents. And I put my answer where the bigger exponent was.
So you subtract?
Yep.
Yeah.
Divide.
When you're dividing exponents, you're really subtracting them. That's the rule. It's like this. That's if I wrote it out, say, Vaughn, that's what it looks like, right? All I'm going to do is cross out the pairs. I got 2 left, right? That's why it works that way. All right? So if I wanted to, I could simplify that a little bit more. What would I get? If I want to simplify that one more step. Not 18, other way around. 81. Remember, it's not this. It's not 9 times 2, it's this. 9 times 9. It's the big number multiplied together that many times. Right? Don't make that mistake of doing 9 times 2. It's 9 times 9. All right? Remember, it's not 9 times 2, it's 9 times 9.
81.
Okay, so as we look at this, anybody see a letter with an exponent that's negative? If you do, let's just circle it right away. Yep. Which one?
So guys, two D's on your note sheet too.
Ryan said this. Okay. Anything else?
X. The second X and the second Y.
Yep. The next x to the negative 4. Yeah, Ryan? Okay, I like Mr. Roy's idea, put everything over 1 right away. Everything that I just circled in red, where is it going to go? Yeah, everything that has a negative exponent, move it to the bottom. This is going to move, that's going to move, that's going to move. Okay. What's going to be left in the top? There's not much, so let's start with that.
Y2.
Y to the.
That's all that's in the top. Okay. What does negative x to the negative fifth become when we move it? Now, be careful when you move it. Okay, when you move it, the only thing affected is the exponent, nothing else. So what's this going to become when we move it? When you move something through the fraction bar, the only thing that can change is the sign on the exponent. Leave everything else the same. Good. Negative x to the positive fifth. Okay, a mistake that I usually see is people get rid of both of these negatives. Nope. The only thing the fraction bar does is it gets rid of the negative on the exponent. Any other negatives? They stay.
Guys, on the note sheet, that's why I wrote on the board. You can see right there on your note sheet.
I see now.
What about x to the negative fourth? What does that become? Austin? What is it? X to the fourth. Okay, one more thing we got to move.
Y.
Yep.
Y negative 2 to the bottom.
Good. Okay, so everything here is pretty good. The only thing that I think looks a little confusing is this negative x to the fifth. Everything else is pretty straightforward. What number is in front of x here, even though we didn't write it? 1. Okay, or a negative 1. Okay, so the way I want you guys to think of this rule, it's kind of like the warm-up problem we did. You've got negative 1 to the fifth power, and you've got x to the fifth power, and then we still have everything else we had before. The x to the fourth, and the y squared. Does everyone see what I did there? It's kind of like that distributive property to the exponents. Okay, let's simplify anything we can here. For now, the top, just leave it. Okay, what about negative 1 to the fifth? We talked about this rule. When you raise a negative number to an odd, it's negative. So you're multiplying negative 1 5 times. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1. What is that, Marcus?
Just negative 1 and fifth.
Yep.
Just negative 1.
Negative 1. Okay, if you have trouble, type it in on your calculator. Negative 1 times negative 1 5 times. Get negative 1. What about this? X to the fifth, y to the x to the fifth, x to the fourth.
X9.
Good. X to the ninth. Okay. What else is still in the bottom?
Then Y to. Wouldn't that cancel each other out? No question.
So somebody just made a good suggestion. Why did you have the same thing in the top and the bottom?
Don't they cancel each other out?
They cancel each other out, yes.
I have a question.
The only thing is, now we don't have anything in the top. So what do we got to put there? We got to put something.
1.
Everyone see why these canceled out?
Hold on, wouldn't that cancel out too? Negative 1 and 1?
Would these cancel out?
Yeah.
No. Big 1?
You can leave it like that, Savon. That's okay.
Okay.
If you wanted to leave it as negative 1, x to the ninth, that's fine. If you wanted to reduce it further, you could, but we've gotten through the part I want you to get through. It's good enough.
How many are going to be on this test?
How many of these?
Yeah.
Negatives? Probably like 5 or 6. 5 or 6.
Sorry.
All right, so look at these directions. Okay, they say.
Three A's on your example sheet, guys, the blanks.
Okay, 2 parts: simplify and then evaluate. So first thing, let's get rid of all our negative exponents. After we do that, okay, guys, it's getting a little loud. Getting a little loud. Okay, after we get rid of negative exponents, I want you to plug in that number for x. Okay, what has to move here?
X to the negative 4.
Where does it have to move to?
Bottom.
Bottom. Okay, so I'm going to be left with 3 over x to the 4th. That's step 1, done. Okay, right with positive exponents. Okay, so put a box around that. That's our first step. What else do I have to do?
Distribute the X, or change the X to negative 0.
Yeah, so now we're going to let x equal negative 2. That's what they told us to do. Because it's negative, what symbol do I want to make sure I use?
A negative.
Parentheses. Right, let's see if we can do this. What's negative 2 times negative 2?
That's 4.
4. Right? What's 4? Do it again. What's 4 times negative 2? Negative 8. One more time. What's negative 8 times negative 2? 16. Good. Okay, if you can't, always use your calculator if you can't do it in your head.
Make sure you put it in parentheses.
Yes, if you plug it in on your calculator, you got to use parentheses.
Wait, can't that distribute?
No, if it was 3 over 15, you could reduce it. Right, anybody need to see another one like this? Everyone okay with this?
Just in case.
One more? Okay, so first thing I'm going to do is put it over 1. Okay, next thing is I'm going to circle whatever has a negative exponent. Okay, in this case, it's a to the negative 2. So when I rewrite it, who can tell me what this is going to be? What's going to be in the top? What's going to be in the bottom? 7 where?
Over.
Yeah. 7 over?
A2.
Perfect. Okay, so there's the first part.
So guys, when you have something like this, just move your stuff around first. Don't try to apply that number right away. All right?
Yep, now plug in negative 3. Okay, so we got 7 over. Okay, Mr. Roy reminded us, make sure you put parentheses. Okay, what's negative 3 times negative 3? 9. Don't worry about what that decimal is, just leave it 7/9. I said don't worry about, don't divide that up.
Well, the test, is there going to be any decimals or no?
No, on the test you can leave it as a fraction, just like that. Okay, example 4, I think example 4 is actually the hardest one, so we get through these, then we're done the hardest ones.
Last one, so last one on your note sheet. Right, last one on your note sheet. I want that note sheet to have a couple examples, guys, that way you'll have some kind of reference for the test on Friday. That's why we're bouncing back and forth. So this one's gonna go on your note sheet, where you got to do the beginning of class. The first sheet you got, on the front side of the bottom.
Ben, can you tell me something I should circle that needs to move somewhere? Anything attached to it?
Oh, it does.
Yep. Okay, so, okay, Ben told us one thing that's gonna move.
I got a note for you.
Eli? Yep. That's gonna move. Okay, what about the negative 3?
Yeah.
Does that have a negative exponent on it? No, if you want to pretend there's an exponent, it's a 1. It's positive. Don't move it. This is going to go to the top. This is going to go to the bottom. So first thing I'm going to do is rewrite it, switching around what I just wrote. 6 is still in the top. Y squared is still in the top. What else is going to go up in the top with it? Y to the positive 5. Okay, so we wrote that. We wrote that. We wrote that. Okay. Let's look at what's in the bottom. Negative 3. X still in the bottom. Anything else that's going to come down in the bottom?
Positive 4x. X.
x to the fourth.
You get us now.
I know what you meant.
You get
That's not.
Okay, anything in the top you can combine together.
Marcus, stop.
Okay, and as a hint, if you see a letter in more than one spot, you should combine them. Anybody see Isaiah?
Don't you just add the x's?
Yep, let's do the x's in a minute. Let's start with the y's.
Oh, y equals 7.
Good. 6y to the 7th. Okay, for now, keep that negative 3. What about x to the first, x to the 4th? Okay, last thing. Can you combine y's and x's?
No.
No. But can you do 6 divided by negative 3?
Yeah. Two.
Sure. Sure, you could reduce it, negative 2 over 1. Y to the 7th stays in the top. X to the 5th stays in the bottom.
We're gonna skip a year. Why are you doing it?
Okay, we're only going to do 2 more, and then we're going to be done for today. So we're going to skip whatever else is more than 2 problems. Okay, 4B. Hold on a second. I don't know if I'm doing
The
that.
note sheet, we're done. So you want to do one?
Yeah, let's do just one of 4B or 4C. Yeah.
All right. So like I said, here's my fraction bar, right? Now, my whole numbers, they don't matter. If you want to, right now, what could we do to both of those numbers? What could we do to both of those numbers? To the negative 4 and to the 10.
Divide them by 2.
Divided by 2, right? Simplify. Remember, this is a fraction is really a division problem, right? I'm going to keep that negative on the top. All right? And like Isaiah just said, all right, guys, stick with me. We're almost done. All right? You guys have not been bad today, so don't ruin it now, okay? We gotta I'm gonna do this one, and then the next one we'll let you guys do on your own. All right? So we divide by 2 on the top. I divide by 2. Ryan, on the top I divide by 2. What am I gonna get?
Wouldn't it be a positive 2?
I'm gonna get negative 2, right?
Why do you get negative 2?
Because remember, this means division. A negative divided by a positive is still going to be a negative. If it was a negative on the top and the bottom, then it would become a positive. But right now, I'm just going to leave it as a negative. The only time you'll make those whole numbers positive is when you have a negative on the top and the bottom. All right? When it's like this, you just leave it. All right? Because it means division. Okay? On the bottom, we're going to divide by 2. What are we going to get? 5. Whole numbers taken care of. Right? They've been simplified. They're done. All right. Now let's just go through, like I said, and the stuff we have to move, we'll move it. The stuff we don't have to move, we'll keep it where it is. So that 8 to the 3rd, men, what do you think? Leave it or move it? This 8. Why would you leave it there, Ben? It's positive, right? The exponent's positive. 8 to the 3rd stays. Spencer, b to the negative 2. Leave it or move it?
No, move it,
Move it. Why?
because it's a negative.
Because the exponent's negative, right? So b to the 2 on the bottom. All right? That's taken care of. On the bottom, Joe, I have a to the negative 3rd. Leave it or move it? Huh? Move it where? Top. And it becomes? Positive, right? B to the 2nd. Tyler, leave it or move it? Why would you leave it? Why? They're doing construction work in the morning. All right. So we got B to the 2nd on the bottom, right? Huh?
What time did you do the announcement?
Huh?
I didn't hear you.
They made a call about their parents anyways. Alright,
What?
so we got -2 here, we got 5 here. Right, there's nothing I can do with those two things. They don't simplify anymore because I already did. What about my A's? What do my A's become, Shazi? 8 to the 6, right? Same base, just add the exponent. Destroy. Nice 6. I'm going to get A to the 6. On the bottom, my B's, Katie? B to the 4th. That's it. There's no more I can do. These aren't the same. They're not both A's and not both B's. So I cannot subtract. All right, I cannot subtract them. Right?
Right, you might have to explain example 5 or something.
Oh. Oh, okay.
Can you just explain?
Sure.
I think it's just 2 5.
Right. So guys, for this, we have something, what is going to do 5A. Guys, pay attention to this because there's a couple like this on your homework tonight, okay?
You guys haven't seen this rule yet.
This is something new. Now we have a fraction with a negative exponent on the outside. Just like we did if it was something like this. I bring that in, right? But now we have this fraction bar here.
Flip it.
So there's a 1 here, there's a 1 there. All right? So I'm going to get, when I do this, I'll get, oops. Oh, where's it going, stuff? I'm going to get 2 to the -4th over 3 to the -4th. I just did that power to a power, here and there.
It's the same thing, it's just a fraction.
Now,
Don't you flip it?
all right, so what's going to happen?
The 3 goes to the top.
3 what? 3 to the 4th. And Ryan, what about, take that out of your ear, please. Pay attention. Just because you might not want to learn right now, there might be other people that want to, so take that into consideration, okay? This is gone. What about that 2? What's going to happen to that? Nope. Somebody help out Ryan. Marcus.
Put the 2 with -4 power on the bottom.
2, and then what happens to the 4?
Turns positive.
Right, don't say, keep it as positive, right? Now, if I wanted to, all right?
I'm not laughing.
Marcus, you want to flatten down your hair.
That's all right. He's got a little alfalfa going on. So Mr. Hager's going to do. Guys, we still have like 6 minutes. So I was thinking in my mind that that number was going to stay at 10 today, but we can change it if you want. So bear with me for like 1 more minute, and then we're done. All right? So Mr. Hager's going to show us real quick. 3. He's going to do 3 to the 4th.
These are big numbers, so we wouldn't expect you to do this back then.
Oh my God.
And then 2 to the 4th. 2 times 2, 4 times 2 is 8, times 2 again, 16. All right? 81 over 16. All right?
So as Isaiah said, basically, if you just notice right away, your fraction just flipped. 3 to the 4th over 2 to the 4th. That's all that happened.
All right? So, again, there'll be a couple like this on tonight's homework. Guys, when Mr. Hager and I made the homework tonight, we made it very similar. Almost, there's a couple problems for each example that we did today. There's a couple with the 0 power, there's a couple like that. All right? So your homework tonight is going to be, it should be on that, no?
Wait, 81 over 16?
81 over 16, yes.
So your homework tonight will be a worksheet.
All right, so guys, just